எல்லாத்தையும் மியூட் பண்ண முடியும்னா பண்ணிடுங்க.
Sir, good afternoon, sir.
Good afternoon. Good afternoon, sir.
Sir, good afternoon, sir. I'm also here.
Good afternoon. Good afternoon, sir.
Yes. தம்பி இப்ப சார் நவ் அவருக்கு ஷேரிங் கொடுத்துறீங்க.
அவரே share பண்ணுங்க sir.
Sir, you can share பண்ணிடுறேன் sir. When you want to start, I will share and start.
Okay, done. Good afternoon, everyone, sir. We are starting the meeting shortly. Another 5 minutes, we'll starting the meeting.
Sir, good afternoon, sir. More detail. Meeting info.
Audio off பண்ணி From fellow Foundrymen. It gives me immense pleasure to welcome all the participants for this meeting. I especially welcome the mentor of National Center for Skill Development, the Southern Region Chairman and the Southern Region Secretary, and the other office bearers of Institute of Indian Foundrymen. Now, this is the first initiative we are taking to conduct the virtual training program for 12 months continuously on 4th Friday of every month between 2:30 to 4 p.m. This is the first meeting we are conducting. The topic we have chosen is adopting AI in foundries. We have invited one Mr. J. Balasubramanian, who is the business, who is the currently working with Ashok Leyland Limited. And I am having great pleasure in introducing Mr. J. Balasubramanian. Mr. Balasubramanian is head of analytics, AI and emerging technologies at Ashok Leyland. He is a dynamic, well-rounded visionary, innovator, and leader with more than 26 years of experience in automotive industry. As a thought leader in data science and analytics management, he is passionate about using technology and data to address the business problems. A practitioner of foresight and horizon scanner for new technologies, he has been leading creative artificial intelligence powered analytical projects that address the need for technology across business disciplines. He is highly sought after for business process re-engineering initiatives, and he has been part of large-scale business transformation projects that leverage digital technologies at Ashok Leyland. He is known as a positive influencer with propensity for leading, mentoring, and managing technical and behaviorally diverse teams. Mr. Balasubramanian holds a master's degree in statistics and he is an alumnus of Indian School of Business. In today's session, Mr. Balasubramanian would be sharing his views on role of AI and machine learning in Foundry, taking us through the opportunities for leveraging artificial intelligence to enhance the efficiency and innovation in Foundries. Now I am leaving the floor to Mr. J. Balasubramanian. Sir, now the floor is yours. You can start the presentation.
Thank you, Alan sir. Thanks for the wonderful the wonderful introduction. And so, good afternoon to all. I see quite a large participation, close to around 59 to 60 people are there in the group. Gives me immense pleasure to be addressing the group virtually. I have conducted this session on a physical basis at IIT Tirupati a couple of months ago. But nevertheless, it gives a great pleasure to connect with a larger audience, for Foundrymen. Because today is a very, very crucial and critical topic which I have been asked to address, especially to the Foundry people. So basically today I would be covering the role and the importance of artificial intelligence in Foundry, the scope of artificial intelligence, how the entire Foundry activity is being transformed through use of artificial intelligence. So these are some of the topics which I would be covering in the next 1.5 hours that's been allotted to me. And I hope that by the end of the session, you will be taking away some good learnings which you can try to adopt in your foundries and in your workplace, and which will help you to actually transform the way the entire foundry activity is being done presently. So let me quickly start off with sharing sharing my screen and starting with the presentation. And so I would like to take at the end of the session, let's you can ask, you feel free to ask some questions which I will try to answer at the best of my ability. Just when somebody saying audio is not clear, am I loud and clear? So that's so because
Yes, you are. You are very,
yeah.
very clear.
Okay, thank you. Just a minute. Let me start sharing with my screen and let's get started with the. Please let me know if my screen is visible.
Is visible, sir.
Yes, sir.
Visible, sir.
Thank you. Right. So let's quickly get into the presentation. So for the next course of 1 hour and 1 hour 15 minutes, I will try to take you through the various facets of artificial intelligence, how the applicability is there in Foundries, the kind of how there's a synergy between AI and the work what we do at Foundries. And definitely it will be of very useful to know people who are very keen and have an aptitude to work with numbers and try out more mathematical algorithms to improve the efficiencies of Foundries. So without much ado, let's get into the topic. So just to be a quick, since I represent Ashok Leyland and I have been a part of this organization for close to around 26 years now. I joined this organization after my graduation, and I am privileged enough to be associated with this organization for quite some time, for a very long time to be precise, and had stint across various functions, which has given me immense opportunity to learn in this organization. So just to, for people who are not aware about Ashok Leyland in much, so we are the second largest manufacturer of commercial vehicles. We have a full range of vehicles from 2.5 tons to 49 tons gross vehicle weight, and buses from 16 to 80 seats. Our annual turnover is 2 billion plus, and we are listed on the NSE. And we have several manufacturing facilities, including 2 foundries, one at Ennore near in Chennai and one at Sri Peramadur. So these are 2 major foundries, and we cater to both in-house and our external clients. So we have and our legacy is close to. We just celebrated this month our 76th anniversary, and it's a very it's a very proud legacy what Ashok Leyland shares in terms of the commercial vehicle business and the manufacturing sector in India. So let's get into the topic per se now, because this is where the entire action starts. So here we are looking at how the topic for the day, as Mr. Dalan said, was about adopting AI in foundries. So just before we start, for example, Foundry is one of the oldest industry mankind has ever known. Today we are entering into an age of called Industry 4.0, but the foundry activity per se started off way back in around 3000 BC, even before Jesus Christ was born. The mankind has known about foundries. Started off with a by where people dug simple pits and poured the molten metal into it to make the metal figures. So that was the start of the foundry, around 3000 BC. From there, it then the first development per se started when we started to work on the printing press. When Gutenberg invented the printing machine, that was perhaps one of the first time when typefaces were manufactured in bulk and the foundry activity started. Move to 18th century, the industrial revolution actually fueled the demand for castings, and then over the next 2 centuries, and around the 19th and 20th century, foundry has evolved to produce multiple types of goods and metal castings and which has been used in multiple type of goods. But today, if you look at the foundry of the future or the foundry of the 21st century, it's a totally different kind of an setup compared to what was there, say 50 or 60 years ago. Though the core activity remains the same, the way the technology has evolved and the way the kind of the tools and techniques that are used in foundry is way different from how the foundry activities were done nearly 50 to 60 years ago. And that's what we are going to look at, how exactly AI is actually playing a role in changing the dynamics of the foundry industry. So to me, the foundry industry, as I said, while the foundry industry has evolved over a period of time, but fundamentally the core work in the foundry is the principles of the manufacturing perhaps remains the same. So in fact, though I'm not a person who has worked in foundry, as well as I'm not a person who has worked in the manufacturing area, but definitely from a third person's perspective, it gives me a lot of opportunity to learn about the entire foundry industry by observing multiple different industries where I have visited. And I find that the commonality between all these industries is in terms of foundry, it remains in terms of how the castings gets developed. For example, we start off with the preparation of sand for casting. Then we look at how do we manufacture the cores, which are which help you to make hollow castings. Then we look at melting of metals, putting the molten metal into the mold, and finally doing the fettling and the grinding work to ensure that the end product comes out perfectly. So the core 5 main activities remains the same. And today's topic is focusing on how AI is actually it will be helpful for in each of these set of activities. So that's what I'm going to explain, how every single activity, though this has been happening for over centuries together, but today how AI can play a much better role to improve the efficiencies of these processes. So that's what we are going to talk about. And when we look at foundry per se, the 7 big challenges what we observe in foundries are: one, the first and most important challenge is on the quality deviation. A lot of scrap, rework, and the customer claims keeps happening. So one of the biggest and major pain points for the foundry is essentially on the quality aspect of it. Second is on the machine downtimes. There are a lot of breakdowns, or there are unplanned maintenance are happening, or machine failures are happening. So these are other major challenges. And once the machine stops, your line stops, your entire activity comes to a grinding halt. Third is in terms of the productivity, in terms of the material, the yield, the kind of human resource, the production and cycle times, they get impacted when because of the high pressure, high intense job. there's always a challenge of getting the best productivity out from the humans and the resources because of the tough working conditions. So this has been the major challenge. Fourth is on the resource usage. Generally, we observe that there are a lot of planning inefficiencies. There are high inline inventories and material waste that happens in the foundries because that's the way the entire business has been happening over a period of time, and there are a lot of inefficiencies have built up into the system, which currently are being addressed through multiple technologies. The fifth and major impact today, when everybody talks about foundry, is essentially on the environmental aspect. The foundries are a place where you which emit huge amount of gases, and carbon dioxide emission is pretty high there, and there are a lot of material usage and energy consumption is pretty high because of the furnace and stuff like that. So that actually contributes to a lot of environmental degradation, and which is again a big challenge today in the foundry industry. The sixth important aspect is on the cost. So today everybody knows that the raw material costs are high, the energy costs are high, the cost of poor quality, it gets translated into the cost of poor quality, and hence the entire aspect of the profitability from the foundry is always a challenge, because it's not the end product what we are doing. It's an intermediate product that gets generated from the foundry, and hence it is very, very important to see how do we actually cut cost and we maintain viability at the foundry levels. And the most and seventh and most important challenge is on the knowledge drain. There's a lot of if you generally go to foundries, we find that people who have been working there for many years are continue to work, and there's a lot of new joinees or people who are the blue collar, white collar, or the blue collar jobs. The blue collar jobs, people who actually no, they don't aspire to get into the kind of jobs that the earlier generation did, because today there are multiple other opportunities, and hence getting a qualified resource for the foundries is always a challenge. And hence, if a retired person, for example, if an experienced person retires, or if a skilled resource quits, there's always a knowledge drain in terms of how the foundry actually operates. So it's very person dependent rather than process dependent, and that is a huge challenge for the foundry. So these 7 big challenges actually define the way the entire foundry activity happens. And today we are looking at how AI can actually help us to as I said earlier, how improve the efficiencies, improve the viability, improve the cost. And as we go along, we will be looking at how some of the tools and techniques of AI actually contribute to the improvement of the entire process in foundries. So when I have been talking about AI and AI and AI, so AI stands for artificial intelligence. I'm sure everybody would be knowing. But sort of, if you go and ask to a layman, what do you mean by artificial intelligence? If you to give an English definition to an artificial intelligence, it means AI is a branch of computer science that deals with the simulation of intelligent behaviors in computers. That's a very technical definition. So AI means computer. Everybody can understand it is a computer which has an ability to think and perform intelligent action. So let me just quickly share with you an example. So if I talk about an autonomous vehicle, I have an autonomous vehicle. Autonomous vehicles are self-driving vehicles where there is no driver and the car is driven by the computer. So a AI system is essentially trained for a car to essentially drive on the road without causing any damage, and the car should be able to recognize a shadow, and it should not stop that the shadow looks like a human, and hence it should not stop, and it is programmed to drive over a shadow. But the same car, when it looks at a signal and sees a human, it is trained to stop. So that's the simplest way of actually explaining what does AI do. So when the computer is designed to think, so computer should not think that, hey, I can drive over a shadow means I can also drive over a human. No, that's not the way. When it sees that human life, when we give the element of human life into the complexity of human life, the computer should understand and then say that yes, while I can drive over a shadow, I should not be knocking over a human. So that's the AI that comes into play. So this is the way the entire system actually gets designed. And if you look at the types of AI, there are 3 major types of AI. One is called narrow artificial intelligence, which is what lot of today we have the Google Voice, the Alexas, the Siris, and Apple iPhones. People who are using Alexas and Siris. So these are types of AI which will do the task that is instructed to them. So for example, if somebody says, "Hey Siri, you or Hey Alexa, play me a music," it will then play you what music, whatever you have asked, it will respond to it. So what you ask, it will respond. So that is called a narrow AI. Then we have a general AI, which essentially will be, it will have more of human cognitive activities. That meaning it will be, today we live in a era that we have a new type of AI called generative AI. Generative AI means people might not know, but people, if I say people, have you know, do you know about Chat GPT, or do you know about Google Gemini, wherein you ask some questions, it will give you a lot of content related thing. It will give you a lot of contextual content. So that is called it has got a lot of cognitive abilities. It can understand what we are asking and react to the situation. So that is called a general AI. And finally, we have the super AI. This is like what we have seen in the movies and all, like the Rajinikanth movie called Robo, or a lot of Hollywood movies which talks about very complex systems. These are all on a fictional basis. Today, we are not at there wherein we have a AI which is really a human. So we have not yet reached and productionized to that level. But yes, people are very soon going to get there. So these are the three major types of AI that actually we live in. So today we are migrated from a narrow AI to a general AI, and that's where the lot of intelligent systems and systems automatically starts to understand and react. So that's where the AI is actually transforming. And if you, as I said, if you look at AI, it has got three critical roles. It can sense. That means it can see. AI systems can see. You like that means all the computer vision programs, audio, and it can hear. That is the audio. If I speak and ask the computer to give me something, it is able to understand what I speak and retrieve. So that is called the audio processing. Then it can comprehend. Like comprehend meaning natural language processing and knowledge representation. So if what I speak in English or what I speak in Tamil or what I speak in Hindi, computer understands what I speak in a natural language and then processes it and then gives me the relevant content. So for example, if I say, Alexa, play me, tell me what is the score now, it will automatically go and log into the cricket portal and give me the score of the match that is going on. So it is able to understand what we speak and then retrieve. That is the comprehension capability of the AI. And finally, act and learn. So this is where the systems are the ability of the system to actually react to situation or take proactive actions. So this is what we are going to look at as we go along in the presentation, how the machine learning and expert systems actually are designed to act and learn for different situations. So using these technologies, we have a lot of AI related solutions that get built, be in terms of virtual agents or speech analytics or robots or recommendation systems, so on and so forth. So for example, I don't know, all of you would be, we would have heard about the current big billion day sale from Flipkart or the festival sale from Amazon and all. So for example, if you go and say that you would like to buy a specific product, automatically Amazon will then give you more recommendation of similar kind of products. Or you are going to a Meta and seeing a page, you like a certain page and you follow. Immediately you will find that all the related interest or related content to that page keeps popping up at frequent intervals. So you will be, or the video reels you see. Suppose you are interested to see a particular reel, automatically you will see the next all the flow is related to that reel. So these are all the recommendation systems. So computer understands what you like and automatically builds up and gives you the recommendation. So these are all the kind of recommendation systems that the AI actually builds. And finally, huge amount of data visualization happens, which essentially is very, very critical for you to understand the trends and identify the patterns. So again, just sticking on to AI, if you see, there are three major branches of AI. One is called the machine learning, which is the base level. Then we have something called the deep learning, which is an advanced level, and the reinforcement learning, which is more of a reward and penalty mechanism for the computer. So under machine learning, again, we have supervised and unsupervised learning, and we will be, and as we look at the presentation today, you will be seeing that we will be talking about many of these algorithms, what has been mentioned here under the machine learning. So you have two categories called supervised and unsupervised learning. Supervised meaning wherein we have one target variable which we want to predict, or we want to we want to study, which is influenced by multiple other variables. So that becomes your target variable. I will share an example as we go along. Then unsupervised learning means grouping or clustering together. So for example, I would like to understand, as suppose there are today I see that around 60 people are there. I want to understand the cluster of people who represent the northern region or the eastern region or the western region from the profile of the people who are participating. I can do a clustering and understand what exactly is happening. So that's an example of unsupervised learning. And there are other multiple tools like dimensionality reduction, which essentially is to compress the number of features or the attributes that we are studying. So these two forms the core of your machine learning. And the beauty is that the more data you feed into the system, the more accurate the output from these models actually come up with. Then we have the deep learning,
मैं
which
चाह
is
रहा हूँ कि इसका भले डिस्पैच ना हो लेकिन प्रोडक्शन ऑर्डर खोल के हम कंजम्पशन तो दिखा लें, प्रोडक्शन ऑर्डर तो कर लें.
pardon, कोई बोल रहा है क्या बीच में? हेलो
Sir, please continue, sir.
Yeah, I will continue. Okay. Yeah.
Please.
With respect to the deep learning, if you see, we have multiple tools like the artificial neural network, which has got again, no, so I will explain, no, we will see some of the algorithms under the artificial neural network, which has got, multiple sub types of network like recurrent neural network, compression network, and convolutional network, and so on and so forth. And no, they are all so this is like our human brain. Neural networks is like our human brain, which essentially is it is connected by multiple layers, and as the information passes through each of the layer, it is processed, and finally the output is given basis the way our humans think. So this is more like this is where the voice processing and the image processing are essentially powered by neural networks. And finally we have the reinforcement learning. This is like your reward and penalty. So this is where the autonomous vehicles and all are powered today. So anything that has to be done on a repeated basis where the system has to learn from mistakes, we use reinforcement learning. So for example, in our childhood, we would have played a lot of video games and all, wherein if there will be multiple hurdles to cross, and there will be a lot of bombardments and stuff like that. And automatically, if some hurdles are going to come, automatically the system understands and it tries to avoid. So that is the way the entire that's the design of a reinforcement learning. So today, for example, as I gave you an example just some time ago in terms of the autonomous car. So if the autonomous car, for example, if it is programmed and if it's not programmed properly, first instance it might knock over a human. But if I program it and say that if you sense a human or sense a collision, you have to stop, wait, and let that person pass, and then you have to move. Automatically, the computer understands that as the learning, and next time when a human comes in front of it, it will stop, and then the person can pass, and then the vehicle will move. So this is a continuous reward and penalty. So if it does good, it is rewarded by by going to the next level. If it is not performing, it is penalized, and then it is trained to perform to the right expectation. So these are all the some of the major algorithms what is essentially available in the artificial intelligence ecosystem, and a lot of these algorithms are actually applicable in the Foundry ecosystem, as we will see when we go along. So just to summarize and finally conclude in terms of the introduction to AI, from A to AI is actually from A to I. You name any industry today, it is influenced by artificial intelligence, be it in terms of automotive industry or biosciences or creative services or data-driven industry, education industry, finance, gaming industry, healthcare, Internet of Things. Any industry, the list is huge, and every industry today is highly influenced by the AI systems, that is actually when the kind of algorithms and topics what I spoke about. So and today, if you see, for example, even every smartphone for that matter, when we have a plethora of smartphone that comes up, every system is actually powered by AI.
Sir, சொல்லுங்க sir.
Sir, you got muted. Sir, JB sir.
சொல்லுங்க sir.
JB sir, you got muted. You unmute yourself, sir.
Yeah. Now clear?
Yeah, clear.
Okay.
Go
So
back to the
where
presentation.
was I? So
Yeah, now it is clear.
yeah. So this is where I'm talking about. So every industry today is actually influenced by AI, and we will see how AI plays a major role in the foundry industry. So coming to the foundry, as I said, foundry, 5 major activities which we have envisaged in terms of the sand preparation or the core manufacturing or the melting, molding, and finally fettling. We will see the applicability of AI in each of these aspects of business. So well, let's start off with the sand preparation. So sand is the fundamental ingredient that is required to prepare the mold and ultimately prepare the casting. And has got a lot of if the right type of sand is not used, or the sand with the right properties are not used, it will impact its strength, the permeability, the thermal stability of the castings, and so on and so forth, and lead to a lot of dimensional inaccuracies, leading to a lot of rejection and rework. So this is where let us see the type of activities that AI can help you to improve the quality and the effectiveness of the sand that is being used in manufacturing of castings. So let's get into see how AI will actually help you. So AI, if you see in sand preparation, has got 4 major aspects. One is we see that collecting of data to see how do we improve the sand quality. For example, if we get the data on the right grain size of the sand, the moisture content, the clay, the temperature, and using a lot of sensors. So we have the DISA machines, the the machines which actually process the sand and all, and you find a lot of sensors attached to it. So those analyzing those data, we have a lot of algorithms to actually understand, analyze, and see what is the grain size, what is the moisture content, and so on and so forth, the temperature, and to check whether the sand is the right quality of sand is actually being used. Then there is the second activity is on the predictive modeling, wherein we are trying to understand what is the sand properties which can lead to casting defects. So for example, if the sand is very hot, or whether the clay moisture content is very high, or there is a lot of air present in the sand, it might lead to the defects in the casting getting manufactured. So we can basis the kind of input that comes in from the sensors, we can really understand as to what is the kind of casting defects that will happen on the sand portion. And again, we have a lot of algorithms to address these issues. The third is on the automated control and automation of the automatic control and optimization of the sand preparation. So this is another major activities wherein we add water, we do the mulling time, the water addition is there, the binders are added, and so on and so forth. So to the extent of how much of water addition has to be done, or to the extent of how much temperature to be maintained, how do we automate? This cannot be a manual task considering the huge quantity of raw material that we process. So how exactly are the automated systems running? So this is where the automated control and optimization AI enabled systems comes into play. And finally, the recipe optimization in terms of identifying the best set of ingredients for the specific casting requirements. So some castings might require to be pressured under multiple different pascals. Some castings might require different porosity, some thickness, and so on and so forth. How do we identify the right the input of sand for these castings is what essentially the AI system will enable you to do. So let's, as we go along, we'll see some of the the work that involves in developing an AI system for these kind of activity, as well as certain algorithms. So if you see in terms of the preparation of sand, so once we get the raw materials such as the sands, the binders, and additive, sensor data collects all the it collects data on multiple processes like temperature, the moisture, and binder ratio, and then all this data is actually logged into the system, and the data, any outliers and any missing data and all are cleaned up, and multiple features are extracted. In machine learning parlance, when you talk about features, means there are different attributes for the variable, for that variable. Suppose, for example, if sand is my the sand is my major variable which I'm trying to study. Sand will have the grain size, it will have the temperature, it will have the particle, and the shape of the particle. There will be multiple features which essentially is impacting the quality of sand. So how do you actually get data on each of these attributes and extract these features to build up an data point for the predictive modeling or the machine learning modeling is what happens in step number 4. Then having identified these features, these are plugged into the machine learning models, what we shall see, and to see how then the study has to whether the grain sizes are similar or whether they are going to be they are going to be impacting the casting process. All these kind of things can be looked at from the machine learning models. And then once we build up the model, there's something called the model validation and training step, which essentially is to test how well my model performs against my prediction. And finally, how do I incorporate into a real-time system so that with the continuous feedback mechanism and continuously build up the model with new data. So these are the essential steps to capture what is the how do I improve my sand quality. And if you see some of the major algorithms, what I spoke about just now, for example, I would like to predict the sand property or look at what is going to be my defect severity basis the kind of sand I'm using. I use an algorithm called linear regression. So this is a this is a building up relationship between the dependent variable and multiple independent variables. So for example, if dependent variable is the number of defects I want to predict, there will be multiple factors which will impact the defects of the variable, and I will build up the mathematical model and then ultimately try to predict the number of defects. Then we have so this falls under the category of supervised learning, which I spoke earlier. Then we have something called the clustering algorithm to actually group the sand into similar kind of group sand on based on the similar kind of properties. So we identify a lot of patterns in terms of what is the type of sand from might be sand from a particular source might have a simpler set of properties compared to sand from some other source. So these are all the kind of properties that actually can be analyzed using algorithms called k-means clustering. Then using another algorithm like support vector machines, which we can classify the sands into different grades. For example, we may have a high grade sand, we might have a moderate grade or a low grade sand, so on and so forth. Whether the basis the sand meeting specific criteria, when we get an input material using the historic trained data, we can immediately classify whether what is the grade of the sand that has been received. So these are done by algorithms like support vector machine. And finally, and I said I want like to automate and look at the optimal binder content ratio and stuff like that. I use tools like neural networks, which essentially it will help me to understand how much of water to be added, what is the kind of moist temperature to be maintained, what should be the moisture content, what should be the clay content in the sand, so that I get the best casting. So that is like like a human who understands each of these parameters and ultimately fine tunes the machine when you does that. But doing it for a large quantity of combination manually is not possible. So that's where the algorithms like neural networks comes into play, and we are able to optimize optimize the recipe preparation for the sand. And so this is not just theory. So there are a lot of foundries which have essentially done that, and they have been enjoyed huge amount of benefits. For example, a foundry has was able to reduce its labor cost in sand preparation by nearly 5 times, from $250,000 to $50,000 through use of automated systems. Then around 20% reduction in operational costs because with the optimal amount of recipe, the optimal amount of proper sand property, the rejection rates came down drastically. Then there has been 80% reduction in the manual adjustments. So earlier there were around 10 adjustments per shift. After the introduction of AI, just to address any exigencies, only 2 adjustments.
Sir, again you got muted. Sir, Balasubramanian sir, you got muted.
Yeah, I think there is some setting that is muting after some time. Yeah, I don't know. Just okay. So I think it is getting muted, but nevertheless, I'll just keep it on. Yeah, and so yeah, screen is visible. Hello.
Yes, visible, sir.
Yeah. Yeah, and finally, there has been a 100% reduction in production downtime from 4 hours to 2 hours. So there's a 10% overall improvement in the original equipment efficiencies. So if you see the benefit of AI, while I am not got into depth of how these algorithms operate, but using these kind of algorithms in the preparation of sand, the foundries have got such amount of benefits in terms of the quality of sand that is getting used. Then coming to just just a second. Coming to the next activities on the core. So core, as you all know, is the hardened sand that actually is used for manufacturing the hollow blocks. And here, this is a very important. If when we want to manufacture the hollow castings and all, if the cores are not in a proper as per the proper specification, it might lead to a lot of casting defects. So this is where AI is actually today revolutionizing the core manufacturing process, by predicting what is the equipment maintenance requirements that is there. How do you enhance the quality control and automate your recurring task in terms of building the cores? So let's see again how different algorithms actually can be helped to in the core manufacturing business itself. So if you again look at the core manufacturing activity, four major sub activities happen. One is, how do I build up an optimal core recipe? That is again using the kind of what should be the optimal recipe in terms of shell box core or hot core or cold core. How exactly can I use what is the kind of properties of sand I should have, so that my core is getting manufactured properly. So for that, I need to have real-time data on sand. I should have real-time data on the binder content, curing time, and so on and so forth. Then for this is being measured by the AI-powered sensors. And then a lot of predictive algorithm essentially is being used to check when the equipment will fail. In core manufacturing, equipment life is very important, because if the equipment fails in between, the core manufacturing might come down. So how do I look at a predictive maintenance for predictive maintenance and proactive maintenance schedules to ensure that machine uptime is maintained? The third is on the defect detection and classification, which will essentially a lot of computer vision is used to check whether there are cracks or holes in the cores and or the sand inclusions, which will help which will impact the castings that is getting produced. So a lot of computer visioning image visioning is used in this activity. And finally, in the fourth major important is, how do I optimize the design of the core? So these are the four major activities where AI is getting used. For example, in defect detection and monitoring, when we have a lot of neural networks to check how the machine life is actually performing. So they are they are very important to predict the remaining useful life of a machine, because they handle a lot of historical sequential data and reinforcement learning. If you remember, I spoke about reinforcement learning as part of the video games what we played earlier. So these systems, the algorithms actually learn from previous defects. When the machine failed, what was the kind of instance that led to the failure? Basis that knowledge, automatically it will learn, and going forward it will be very helpful to predict what is the remaining useful life of my core manufacturing machine. Then again, lot of classification algorithms to check whether the machine fault is happened or not happened, or what is the reason for machine fault. We use some algorithms like random forest. Then we have another algorithm like decision trees to classify the cores, good or bad. So again, we might have multiple, we might manufacture cores in huge amount of quantity. How do we actually, we can't manually go and check whether the cores are actually good or bad when we have a huge amount of data with their specifications. So using that data, we use a lot of algorithms like decision trees to check whether if the data is all in line with the specification, it classifies the core as good. If it is not, then it classifies the core as not good. So that's where the decision tree algorithm comes into play. Then we have to predict the number of cores required, we have a lot of time series forecasting and demand forecasting algorithms. And finally, we have the clustering algorithms to essentially group the type of cores in terms of their characteristics. So again, like what we saw in sand preparation, we have again multiple set of algorithms which we can use in the core manufacturing. And again, in recipe optimization, such as use of sand binders and additives, we use multiple algorithms here, again like genetic algorithms, which are used to iteratively mix the sand and the binders, because this is like humans genetic algorithms actually mimic the behavior of the humans. So for us, whenever we want to build out certain thing, we iterate, we pour different binders and mixtures, and finally arrive at the right combination. But in a real-time basis, using a large amount of quantity is very difficult to do. And that's where the genetic algorithms come into play to essentially identify what kind of binders properties has to be used to ensure that the core is manufactured properly. Then we have to ensure that the core hardness is maintained. We have something called the gradient boosting algorithms, which we are used to which we use to predict and to check whether the core hardness is maintained across the different cores that is getting manufactured. And finally, we have the artificial neural networks to actually see that how do I build up the optimal recipe of for the core. Like the sand, when I said we have the optimal recipe preparation for the type of sand that has to be used. Similarly, we use the AI and artificial neural networks to check how much of binders have to be added, how much of what should be the temperature that should be maintained, what should be the design specification that should be there for the course. So that is maintained through a concept called evaluated through a concept called the artificial neural network. So it helps you to improve the quality of course. And with this, the automated systems, again, we have a lot of algorithms to actually run this process through algorithms like Bayesian optimization, which will essentially improve the quality of the core, but also reduce the energy consumption that is there used in terms of core manufacturing. So these are all mathematical models which and the reinforcement learning what I spoke in SAN, that also has applicability in the core manufacturing in terms of maintaining the temperature and looking at the optimal material characteristics. So these are the algorithms. When we tune the system with these algorithms, the entire process can get automated, and it can lead to a lot of benefits in terms of consistent core strength, getting a very good dimensional accuracy in the cores, reduce defects in terms of the cores getting manufactured, and ultimately leading to lower scrap rates. So these are all practical benefits that foundries have accrued by adopting these kind of algorithms. So whatever I have said, they are all algorithms which have been used by multiple foundries across the world, leading foundries, and they have realized these kind of benefits. So for example, in consistent core strength, the algorithms help you to maintain the strength to 2 megapascal compared to an earlier 10 megapascal. So the excess strength was actually moderated and leading to a reduction in number of material, the kind of material required, and it was maintained at 2 megapascal itself, which was sufficient for the kind of castings that was required. So these are some of the AI driven initiatives in terms of core manufacturing. The third is on the melting process. Again, this is a major area in the manufacturing of castings. Melting of material, high energy consuming activity. But today, AI is also playing a very critical role in seeing how do you actually have the melting, how can you influence melting with the AI powered algorithms, and by in alloy composition, or by looking at real time process of the machines, are giving operators training to operate the furnace in a very efficient way. So if you see melting, there are 5 major activities again. One is use of AI in the real-time process control for detecting any anomalies. Anomalies meaning when we talk about anomalies, it is essentially the deviations from the set prescribed process. So there could be temperature, the deviation in terms of temperature or the chemical composition or the pressure to drive consistency in the melting quality. So all these things, there could be deviation. So how do you use AI to actually measure the real-time process control? The second most important thing is on the alloy composition. How do you maintain the optimal alloy composition for different kind of metals that is being used so that you get the perfect casting? So again, how do that's where the role of AI is very, very critical in terms of identifying the optimized alloy composition for the best casting manufacture. The third is on the energy efficiency. Again, this, as I said, this is a very, very highly energy intensive activity in terms of consumption of energy, and with a huge energy cost. Use of the algorithms like ANS, artificial neural network, has helped foundries to reduce the energy consumption by 50 to 55% in the melting process by optimizing the settings of the furnace. So that has been the major activity. Fourth is on the adaptive control system, which will automatically adjust the furnace settings based on the external conditions, or when the raw material and the environment conditions change. the furnace automatically understands the changes in these elements and sets the conditions. And finally, the operator training and guidance. How can we use AI to train our operators to essentially maintain the furnace? So based on the real-time data and the changes in scenario, how do you actually use that? So these are some of the areas where AI is extensively used in the melting process. So I would not get into depth of these slides due to paucity of time, but still, in the when we talk about the process control, the real-time process controls, multiple algorithms actually capture data on the internal and external environment, and using different algorithms, they actually process and see what is the impact on the melting activities. On the alloy composition, here I might spend some time. There we have multiple algorithms like the Bayesian optimization, which I spoke earlier, to arrive at the optimal optimal composition of the alloys. And also you can cluster different alloys based on their similar characteristics using clustering algorithms to identify what is the patterns and relationship between multiple alloys and the impact on the castings. And finally, we have neural networks, which actually can be used to predict if you have a new alloy that is coming up. Based on the past learnings from the alloy properties, we can predict what would be the alloy properties of the new alloy that is being produced. So these are some of the major algorithms which is used in the alloy composition. And in terms of energy, this is again a major activity where we use a lot of time series algorithms like time series forecasting to predict what will be the kind of energy consumption that is going to happen in the foundries, and use real algorithms for the real-time energy management. So this is another major area where the predictive algorithms like time series and the regression modeling is a linear regression essentially is used to predict what is the energy consumption that is going to happen in the foundries for given set of castings and the energy requirements. And finally, on the adaptive control system, here again, this is where the system should learn whenever it encounters a mistake. It should self-learn, and it should take a corrective principle through reinforcement learning. So this is where the reward and penalty mechanism comes into play. And so, for example, when I use reinforcement learning on parameters like temperature, fuel injection rate, and airflow, how do I use it at an optimal quantity to maintain the melting conditions? So I should not be passing out a huge amount of air, or I should control the airflow. I should not drop the temperature drastically. I should not inject my fuel in a very, very rapid rate. I have to control these things. So, am I audible? Because yeah. So I need to essentially control these parameters on a very, very optimal level. And that's where the reinforcement learning comes into play. And similarly, the fuzzy logic, what I have mentioned in the second point, is essentially like the humans, it automatically adjusts the furnace settings based on the metal composition, the temperature, and the output quality. Then we have other some advanced algorithms like model predictive controls, which essentially anticipates the kind of changes in the furnace condition that's going to happen. So the fuzzy logic will adjust based on a situation that has happened. Model predictive control will anticipate the kind of changes that is going to happen. So, for example, if it is going to be cloudy outside, means automatically it will anticipate that there's going to be a temperature drop that is going to happen in the external environment, and automatically preempt the furnace to change the settings to maintain stability and efficiency. And finally, we use again neural networks is used extensively to see how can we look at the sensor settings and look at adjust the sensor settings to ensure that our desired outputs come into play. So these are some of the major algorithms what we use essentially in terms of maintaining the furnace settings and the melting activities. And if you see, if I summarize the benefits of the AI in melting, with this through AI, there's been a lot of efficiency in terms of energy consumption and resource utilization. The quality consistency has improved significantly across foundries in terms of the alloy compositions that has been there. Machine downtime has come down very significantly because of the predictive models, which will essentially predict when the machine breakdown or the furnace breakdown essentially is happening. And finally, scalability of the system is maintained because huge number of combinations, even though there might be millions of combinations of the alloys and metals, and the temperature combinations, the kind of castings that has to be developed, the scalability of and the flexibility of AI systems enables you to handle a huge quantum of big data at any given point in time. So that's the role of AI in the melting process. We have two more processes to go. One is on the molding process. Again, this is where molding, as everybody knows, is where the molten metal goes into the molds to essentially form the castings. So here again, AI has a major role in terms of maintaining the temperature at which the molten metal goes into the mold, the kind of the mold, how does it get filled with the molten metals, and also look at the properties of the molten metal that impacts the kind of quality of mold. So some of the algorithms, again, some of the areas where AI is essentially used is one on the predictive maintenance of the molding, to check the molding machines or the mold, if whether the mold is going to fail or whether based on the deterioration in the quality of mold, when it will actually fail. So this is where the predictive maintenance comes into play. Second is on the defect detection and classification. Lot of image recognition is used here because this is where the physical product comes out for the first time. So here the image recognition identifies cracks, voids, porosities, or the fissures due to the cracks and stuff, sand inclusions and so on and so forth. How do identifying these things with the human eye will be very, very difficult, and that's where the image recognition comes into play. Then we have the automated mold finishing, which essentially takes care of the surface grinding, the polishing, and cold for check how the consistency of the mold is maintained. Then we have again virtual mold simulation. A lot of simulation is used to design new molds. So to physically designing molds is a challenge. So when we have complex design, that's where 3D simulations comes into play through virtual molding. And finally, mold maintenance. We use a lot of pattern recognition algorithms to check and measure and see how can we extend the mold life. So 5 areas where AI can essentially be used in the molding process is what I have shown here. And some of the major algorithms that we essentially use in terms of the machine breakdown or predictive and proactive maintenance, we use a lot of predictive algorithms like the linear regression and the neural networks to actually predict whether the based on the sensor data, whether the temperature and pressure of the molds, whether this mold is going to develop any failures and stuff. So whether or use even algorithms like logistic regression to check whether the mold is of good quality or bad quality. So these are some of the mathematical powered supervised learning algorithms to look at whether to predict the failures, likely failures of the mold that is going to happen. In terms of defect detection, as I said, computer vision is essentially used to understand as to capture the high quality images of the casting and the molding and to check whether there is any defect that is emerging from the on the molds. And defect classification, we use algorithm like the convolutional neural network. This is where this is one of the major algorithms used to classify the defects into good or bad castings or good or bad output. And use of quality assurance algorithms is essentially done to classify whether the casting is a good casting or a bad casting. So some of the essential major activities that is happening on in terms of computer visioning is happens at this point in time. I will try, if time permits, I will show you a video what I have enclosed here. Then the automated molding is where the reinforcement learning algorithms comes into play, because whenever we talk about something called an automation, the system has to learn on its own for the changes. That is where the reward and penalty mechanism, the automated meaning itself. By automated, we mean that system is able to perform tasks on its own. So here and when we talk about the molding activity handled by complex robots, here we have a lot of reinforcement learning algorithms built into the robots to actually identify and perform the repeated task without any issues. So the reinforcement learning, what we saw earlier as part of machine learning, they are programmed into these robots and continuously help to improve the robots performance by optimizing cycle time and reducing the defects in terms of the output, the molds that actually are available for producing the castings. And in the virtual mold, as I said, this is a area where we use a lot of simulation to build up the mold. We will cover this in the subsequent slide when we actually reach there. So this is where the simulation essentially happens. And ultimate, the final one is on the mold maintenance. This is very, very important because we will not be, we need to look at, preparing a mold itself will be a very, very expensive proposition, given that to the specification it has to be manufactured, because it is the shape that gives life to the casting. So how do you actually measure or maintain the mold? That through predictive modeling or through optimized maintenance. This is where we use a lot of machine learning algorithms, like neural nets, or to understand how do I optimize the mold, to prevent, or how do I optimize the specifications of the mold. Any change in specification or any change in the dimensions of the mold, how do I actually am able to detect that that change has happened, is done with predictive models and the neural nets to understand the adherence of the mold to the specifications. And for example, one of the foundries has used this kind of an predictive algorithms to schedule its resources, and allocate the resources for the maintenance activities of the mold. So whenever we are looking at mold maintenance, how do you there's going to be a downtime in terms of the mold availability. So how do you actually allocate resources to go and handle that downtime is where very, very critical activity. So you need to predict the schedules and the downtime of the molds, and also look at use of algorithms to see whether the mold is efficient or not. So this is where the mold maintenance using AI is essentially happening. And anybody? Hello? Yeah. Okay, I'll come back. So some of the major benefits in terms of now the mold is essentially in terms of improvement in quality by reduced defects. 50% reduction in quality issues has happened through use of AI. Productivity in terms of there has been a 20% reduction in unplanned downtime of the machines due to the due to higher uptime of the molds, leading to increased productivity and reduction in waste. 60% reduction in material cost and waste has come down by use of AI. So everywhere, so I'm trying to correlate whatever how the AI is actually benefiting each of these activities. And finally, if you look at the fettling process, this is the final process where it involves it's again a very, very labor intensive process, involves the giving the final shape to the product through grinding, through polishing and stuff like that, to smoothing and giving the final shape to the product. So again, AI has a major role in terms of identifying defects through image recognitions, by using robots to do it or do an automated process, by using adaptive process control to automate the entire process of adjusting the parameters for the fettling. Look at what is the kind of right tools to monitor the condition of the fettling through tools through image recognition. Then how do look at the bottlenecks of analyze the process data and look at which are those processes which actually are bottlenecks to the fettling process. And finally, look at AR VR system, the augmented reality and virtual reality, to train workforce on how to do fettling process. So these are 6 major areas where AI has got a major role in terms of improving the fettling process. So, for example, when I talk about defective and defect identification system, so AI enabled camera based system. So you see a lot of cameras fitted in foundries capturing the images at real time and then comparing with the historical images and check whether the irregularities are there in the castings that is getting produced, and looking at classifying it as a good or bad casting. So these are the some advanced algorithm like UNet, MASK, and YOLO. So these are some of the algorithms that actually are used in terms of AI-driven vision systems for identifying the defects in castings through computer vision. Then in terms of the process optimization, again, when we talk about optimization, here we are looking at how much of time has to be set for the grinding of the casting, how much time should be spent on the smoothing, what is the resource availability to do the activity. So we need to have augmented process through a concept called linear programming, which essentially is used to allocate resource, schedule production, and optimize the settling process. Similarly, when we talk about automated systems, we use reinforced learning, wherein the system will automatically understand how to allocate the resource and also look at monitor the parameters as to how to control the entire the specification of the fettling process. And then the use of robots to essentially do the fettling is hugely applicable in terms of automated cleaning of the castings, and a lot of algorithms are used to are program. The robots are programmed with these kind of reinforced learning to have a high precision job done on the fettling lines. So I'll be rushing a little bit because these are some of these are very complex activities, but no, these are the entire activity that has been in this industry 4.0. Robots play a critical role, and they are powered by AI power algorithms. So, and in terms of predictive maintenance, we find that no, the health monitoring of the fettling equipments is very critical, and we have a lot of statistical algorithms like regression and to predict whether the equipment is going to fail, or whether the equipment is what will be the precision of the equipment in terms of producing a good quality product. So these are the some of the areas where the AI is applicable in the fettling process, and the key benefit is by using the AI, we have got around 40% reduction in scrap, or in terms of predictive model, there has been an increase of 30% tool life, and machine downtime has come down by 50%, and 20% reduction in maintenance cost. So these are some of the activities our Foundry has enjoyed. And similarly, safety also has improved because of the the manual, because of the requirement for the use of automated fettling. The manual fettling has been removed, and there's been a 60% decrease in safety related incidents, and also in terms of the reduction in the workplace injuries, because these are all very critical high specialized skill jobs which now has got potential to cause injuries. And with the use of automated fettling, these amount of activities have significantly been reduced. So these were the 5 areas which I have covered where AI has played a major role. And some of the other areas is essentially on the quality inspection, where a lot of image recognition happens to identify the adherence of the machines to quality. You through pattern recognition algorithms, or the visual defects, image scanning, and of the machine part, and so on and so forth. So these are some of the and if you look at, these are some of the major technologies, whatever I spoke over the last 45 to 50 minutes. These are some of the major technologies that is used in foundries in terms of AI. We have the machine learning, the computer vision, predictive maintenance systems, robotics, decision support systems, simulation, optimization of the supply chains, quality controls, defect prevention algorithms, and energy optimization algorithms. So the foundry, if you ask me, is a gold mine, or a vast playground for applying AI to increase the efficiency and productivity of the entire system. And just to summarize the different types of algorithms, what I spoke across these areas. So the next 2 slides essentially gives you an idea about the type of algorithms and the applicability. If you see, linear algorithm is used in sand, and it is used in the fettling process to predict the outcomes of the sand, or predict the defect severity. Logistic regression is used to understand the probability of defects, and it is used for binary outcomes. So like that, I have mentioned multiple algorithms. So these are two slides. I won't go in detail of these slides, but these are the major algorithms that are used in the foundry, for different kind of activities. So somebody wants to understand, okay, how do I predict the useful life of a machine? You can use a reinforcement learning. Somebody wants to predict how much of what should be my sand property? You can use linear regression. So these are some of the major algorithms which we have essentially used in the foundries for different set of activities. So these 2 slides cover the entire set of algorithms what I have discussed now. And also, I'll just give you quickly take you through one of the examples of how the AI is applied in a foundry. So I'm just giving you an example of a case where we needed to predict casting defects. Okay, so it is dependent on 6 variables. For example, mold temperature, pouring temperature, cooling rate, alloy composition, pouring speed, and mold material. So these 6 activities actually are influence the way the casting defects happen. Okay, so my job is to essentially use these data points across these 6 variables and predict whether my what will be the number of defects that is going to happen in the casting. So if you look at the output, I would like to have the number of defects that is going to happen. So how do I do this? So I have these 6 dependent variables, and I have the output variable. So here what I'm going to do, I assume that I have got around 100 data points on these aspects. So for example, the first observation has an when the molding temperature is 574.91, pouring temperature is 1306.29 Celsius, cooling rate is at 11.42, alloy composition is at 61.03, pouring speed is at 5.52. I have a 75 defects. So like that, I have got around 100 different observations. So assume that I am now going to pour at a certain level across these with a specific pouring temperature or cooling rate. I would like to understand how many defects I would be left with, or how many defects are likely to come. So this is where we build something called the linear regression. And when the model is actually built, the dependent variable being the number of defects and the independent variable being the 6 variables what I showed. And when I run the model, I get a tabular column like this, which gives me the column of the coefficients. Then I have the other column. So first and last column are the critical ones which we need to essentially see. So for example, if I look at the last column, wherever the p-value, if it is less than 0.05, that means that variable has got a significant influence on my output variable. So for example, here if we look, the mold temperature and the pouring temperature, these two are the critical variables which influence my casting number of defects that comes into the casting. So here, and if you look at the signs of this variable, for example, the molding temperature has got a positive sign, and the pouring temperature and so molding temperature has got one positive sign, and the cooling rate, cooling rate has gotten a negative sign. Okay, mold temperature, pouring, and cool rate. So these are 3 essential variable. If you look at the molding and pouring temperature, if the molding temperature and pouring temperature are at a very high temperature level, that means it will lead to more defects. The higher the temperature, there could be more number of casting defects, because it is beyond the optimal temperature that could impact the life of casting. And similarly, the cooling rate is negatively correlated with the casting. So the lower the cooling, or if the cooling is faster, this will help us to reduce the number of defects. So this is the way we have to relate the mathematics of this entire model with the number of defects. So very high temperature of the molten metal will also lead to a defect in the casting. And if my molten metal cools faster, then the number of defects will actually come down. So this is an example, a simple example of how we can use a concept called linear regression to predict what is the number of defects that is essentially going to come in the casting. And while we have said the use of AI, we have explained the use of AI. It has got severe, it is not an easy task to just go and apply AI into the Foundry. There are major difficulties. One is on terms of availability of data. Second is on the expertise to actually build these models and evaluate the outputs and interpret the outcomes. Third is integration with the existing systems. So suppose we don't have a system to capture data at all. It's no point in going and putting up all this is AI system, because they are very cost intensive, and the ROI, the return on investment, will not be visible immediately. It will take some lot of time to actually mature and realize the benefits. The fifth one is on the security and safety. We talk about automated systems. We talk about a lot of areas where use of robots and automated system. But suppose if they are not secure and they are prone to hacks and cyber security issues, they might act in a way that will actually lead to a lot of challenges in the Foundry operations itself. So they are highly security intensive. And finally, change management. It is a culture change that has to happen. So when the AI, as I said earlier, AI is not going to replace humans. It is only going to aid humans. But if humans are not upskilled in terms of using AI, ultimately it will replace humans who are not skilled in using AI. So that is where the challenge of AI comes into play, and it will have a lot of change management issues also, because people have to first understand how to use AI and also have confidence in terms of applying AI in the jobs. So these are some of the major challenges what happens on the AI. And some of the case studies what I would like to also share is like these are some of the foundries. For example, Cummins has used predictive maintenance to reduce the downtime. Vubaka, one of the largest foundries in US, uses extensively 135 robots from core manufacturing to packaging to drive efficiency. Sandvik uses automated tools for mold designing and also look at parameters to AI to predict the behavior of molten metal. NIMAC is essentially using a lot of data models to predict casting defects and also look at how does it reduce the occurrence of defects in the production quality issues. And DSL actually uses supply chain optimization to improve the material procurement and reduce inventory levels in terms of the foundry operations. So there are a lot of case studies available in the public domain of how the foundries have been using AI to actually improve their efficiencies. And some of the other emerging trends are in terms of foundries are additive manufacturing, the digital twins, use of advanced robotics and advanced simulation. So these are some of the additional trends. Additive manufacturing today is essentially used extensively at foundries to manufacture to get the components prepared. Physical components are getting replaced with components done through 3D printing and additive manufacturing. Digital twins is another major area which essentially is very initial development cost is high, but subsequently used extensively for training and evaluating the efficiencies of the system, and this is very prevalent in the manufacturing area. Advanced robotics, as I said, used for the automation process, especially in the fettling process or in the terms of the melting and molding process. And simulation is used for more extensively in the mold designing. Virtual mold designing simulations are being used. And some of the final benefits, as I said, just to summarize, across, if you look at the entire spectrum, there are a lot of benefits in terms of reduction in lead time, reduction in casting defects, not around 10% reduction in simulation efforts, and 50% reduction in machine downtimes. One of the biggest benefits of AI is a higher uptime of machines and better quality of the output, reducing the risk of stockouts or the having an optimal inventory management. And ultimately use of AI also is on the human front. It also helps you to monitor in terms of whether the workmen are wearing the PPE kits. Use of image recognition helps you to identify whether the people are wearing the protective gear, whether the equipments are in the proper shape, and based on that alerts get generated if the deviations are happening from the system. So these are some of the major advantages of AI in Foundry. And finally, the last slide, I would like to just say that today foundries are getting transformed to two major activities. One is technological advancements, as well as they are suffering environmental challenges. When I talk about technological advancement, there is a lot of pressure in terms of the foundries need to move to lightweight aggregates. For example, today we see a lot of EV vehicles coming on road. In terms of automobile, if you see my sector, EV vehicles are taking precedence. EV vehicles, as you know, runs only on a battery and motor. It doesn't require an engine. It doesn't require a transmission and so on and so forth. So you need not have a heavy vehicle actually built. It is going to be very lightweight, but it has to also because the more the weight, it will lead to a higher battery discharge. So lightweighting of material is very important for higher yield and higher productivity of those kind of things. So, and these vehicles also have very complex design, and there's a lot of requirement to do a rapid prototyping because the customer changes are so volatile that how you might not have the time to go back to the drawing board and start from the scratch. So you need to have the rapid prototyping available, wherein 3D printing comes into play. That's where the 3D printing plays a very major role. Then the process capability and process stability to scale up the production is very important. And finally, you have seen stringent quality standards to meet because of the huge amount of norms that is in place. On the environment side, if you look at it, the major challenges are in terms of sustainability, recycling of material, reducing of scrap, looking at sustenance of the skilled workforce, and also ensuring that there is no disruption in the supply chain. So, but when we balance out these two, I'm sure the use of AI will help you to enhance the efficiency of the foundry, drive innovation, and also help the foundries to remain competitive in the coming times. With that, I have come to the end of my presentation. Though I have rushed out a little bit, but the content has been vast. But definitely, I'm sure you would have had an idea about how different algorithms or different mathematical models can play a vital role in terms of the foundry operations and help you to improve the efficiency and the productivity of the foundry. Thank you very much.
Thank you, Mr. Balasubramaniam. I have a few questions. I think I would very heavily draw on the last 5 minutes of your presentation.
Yeah.
Then the real thing is coming out. One is, one shoe does not fit all. One shoe
Yes, sir.
does not fit all. Are you able to hear me?
Yeah. I am able to hear
Yeah.
you.
One
Mr. Roy,
shoe
if
does
you
not
could just
fit
mute.
all.
Yeah.
I think a lot of work has to go into collection of data
Yes.
because each foundry is different from the other.
Yeah.
So enormous amount of data has to be collected, and there, I think to go across the board on all processes may be very difficult. We have to start somewhere. Data collection, data analysis is very, very important. And I can also make out from what you're saying, the man-machine interaction, machine learning will be something, but, regression analysis, all that, the process control, knowledge of process control is very, very important.